5-3, slope-intercept form. So our objective is to write linear equations using slope-intercept form and to graph linear equations in slope-intercept form. And our essential understanding is that we can use the slope and the y-intercept of a line to write and graph the equation of that line. And as you'll find, there's many ways to approach graphing lines. Slope-intercept form happens to be the easiest to graph. There's other ways to write lines that are easier to do other things that we'll do with them later. But for graphing, slope-intercept tends to be the best way to graph a line. So first, before we get into lines specifically, let's talk about a family of functions. Okay, so a family of functions is a group of functions with common characteristics. A parent function is the simplest function with these characteristics. The linear parent function is y is equal to f, or in function notation, f of x is equal to x. Okay, that would be every input is equal to the output. So if I plug in 2, I get 2. Plug in 3, you get 3. Plug in 4, you get 4. Okay, which would make a line like this one in red going at a diagonal positive from left to right. Okay. Look at these other lines. Y is equal to 2x and negative 1/2 x plus 1. Okay. These are all linear equations. Okay, and different linear functions. So a linear equation is an equation that models a linear function. In a linear equation, the variables cannot be raised to a power other than 1. So y is equal to 2x is a linear function, but y is equal to x squared and y is equal to the x power are not linear functions. That happens to be a quadratic function. That happens to be an exponential function. Okay. We'll get to this one later. I don't know if in this class we'll be able to get to this one too much, but we'll see. The graph of a linear equation consists of all ordered pairs that are solutions to the equation. So every point on this line, 1, 1, 2, 2, 3, 3, 4, 4, those are all solutions to this linear equation, y is equal to x. Graphs of linear functions may cross the y-axis at any point. They could cross there at 0. It could cross there at negative 3. And the place where it crosses is called the y-intercept. Okay? So a y-intercept of a graph is the y-coordinate of a point where the graph crosses the x-axis. All right, so the slope-intercept form, which is going to focus on the slope and the y-intercept of a linear equation of a non-vertical line, is y is equal to mx plus b, where m is the slope and b is the y-intercept. Okay. You'll see those letters. It kind of seems like M is a weird letter for slope. But if you think about it, there is a reason why, and most of our geometry that we graph is in a Cartesian plane named after Rene Descartes. So some people think it's because M is an unknown, but in French, the word to climb means monter. So it's kind of understood that M is slope, and slope means how steep a line is. So could come from to climb. Anyway, no matter what we use for the variable, we're always going to use M for slope and B for our y-intercept. Okay, so if we look at the graph, or if we look at this equation, we can very easily make an equation, or sorry, we can easily find the slope and the y-intercept of this equation. The slope is going to be 5. The y-intercept is whatever is back there. So the y-intercept is -2. So we'll graph these in a few seconds. But if I was going to graph it, I would start there and then use the slope to help me get the next point. Okay. So my Goddddd problem says, what is the slope of y-intercept? Of -1/2 x plus 2/3. So the slope is -1/2 x. Sorry, just -1/2. Whatever number is in front of the independent variable x, that is the slope. The y-intercept is 2/3. How did the graph of the line and the equation in part A change if the y-intercept is moved down 3 units? Well, if the slope is the same, the steepness of the line, which would be going down, which would kind of look kind of like that, the steepness of the line would be the same no matter what. If I wanted to move the graph down 3 units, the graph would just be lower. Okay? And if you're looking at this on a xy plane, a Cartesian plane, so it would start here with an intercept of 2/3. Now it would be down here with an intercept of 3. So the slope would still be the same. It doesn't change in steepness, but the location of the line does change. Okay, so write an equation of a line with a slope of -4/5 and a y-intercept of 7. So now we go the other way, and I can very easily write my equation because I have slope, put the variable, and then my y-intercept, which happens to be a +7. That's it. Slope, intercept, form. My Goddddd problem, what is the equation of the line with a slope of 3/2 and a y-intercept of -1? So y would be equal to 3/2 x minus 1. Okay, so when we set up these equations, right, if we know the slope and we know the intercept, this should be pretty straightforward. Which equation represents the line shown? Okay, so for the graph, if I look at the graph, I need to pull out 2 things. I need to pull out the slope and the y-intercept. Well, y-intercept is easy. It's wherever the graph crosses the y-axis. So the y-intercept is -2. I don't really care about the x-intercept for graphing for this form, right? Because it's slope-intercept, it would be y-intercept. But if I notice that that's a nice point right there. So to go from one point to the next point, as I go left to right, I'm going to go up to right 1. So remember, slope is rise over run. So this would be 2/1, which would be 2. So I look through these equations, and I find something that has a slope of 2. No, yes, no, yes. And a y-intercept of -2. No, yes. Okay. What do you expect the slope of the line to be from looking at the graph? Look at the graph. This slope is going down. I would expect it to be negative. Okay. What's the equation of the line? So again, I need my slope and my intercept. My intercept is going to be 2. My slope is down 1, right 1. So that's -1/1, which is -1. So my equation is y is going to be equal to -x plus 2. Right? I don't need to write the 1 in front of the variable right there. Okay? Ooh, whoops. -x plus 2. Okay. Does the equation of the line depend on the points used to find the slope? No. Because if I start there, or sorry, let's start up here and use these 2 points. Well, that's 1, 2, 3. That's down 3, right 3. So this would just be 3/3, which would still be -1. So no matter what points you pick on the line, the slope is always going to be the same thing. And the y-intercept is not going to move, or else you're going to have a different line. Now, we could use these 2 points and write an equation in slope-intercept form with these 2 points. So what equation in slope-intercept form represents a line passing through points 2, 1, 5, -8? Now in the next section, we will see a better way to do this. But for now, let's see if we can do this. So first, the equation is slope-intercept. So we need to find the slope. So remember that the slope is equal to y2 minus y1 over x2 minus x1 if we have 2 points. Okay, I can use either point I want as long as I start with the same one. Let's start with -8. So that's -8 minus 1 over 5 minus 2, which gives me -9 over a positive 3, which gives me a slope of -3. Okay, so now I know my equation for slope-intercept form is y is equal to mx plus b. Well, if I use either one of these points, and let's use the easier one, smaller numbers, I know an x, I know a y, and I have the slope. Okay? That just leaves b. So let's plug it in and let's solve for b. So y is equal to 1. The slope is -3. X is 2. And now we have b. So 1 is equal to -6 plus b. That's 6 to both sides. And we get that b is 7. So now I can make my equation y is equal to the slope, -3, x plus 7. Ugly negative there. Okay. Let's look at the same problem in our Goddddd problem. Okay. So what equation in slope-intercept form represents the line that passes through 3, -2, 1, -3? First, let's find the slope. So that's y2 minus y1 over x2 minus x1. So that's -3 minus -2 over 1 minus 3. So this changes there. So we have -1 over -2. So that is a positive 1/2. Okay. Neither one of these two look particularly easier. So let's just pick the one that's got one number that's smaller. So y is equal to mx plus b. So y is -3. My slope is 1/2. X is 1 plus b. So that's -3 is equal to 1/2 plus b. Subtract 1/2 from both sides. And we get that b is equal to -7 over 2, 3.5. Okay. My equation then is y is equal to 1/2 x minus 7 over 2. It's okay to get fractions. Maybe it makes the problem a little harder, but not too bad. Okay, so the point of all this is that we can use the slope and the y-intercept from an equation to graph the line. Okay, and graphing is probably the most important thing that we can take away from this section. Okay, so what is the graph of y is equal to 2x minus 1? The easiest way to graph a line is to put it in slope-intercept form. Thankfully, it's already in slope-intercept form, and I can tell that because the y is by itself. Okay, so once I have this equation in slope-intercept form, start with the intercept. Put a dot at y is equal to -1. What we're really doing is we're making a table. Okay, so like any other graph, if I'm not sure what to do, I could always make a table and plug in numbers. And if I plug in 0, I would get 2 times 0 minus 1 is -1. So if x is equal to 0, right, if we're going 0 left or right, my answer is going to be my y-intercept. Now I could start plugging in numbers like this and like this and like this and see what I get and graph the rest of the line. But the easier method is to use the slope, which is 2 over 1, okay, which means up to right 1. up 2, right 1, up 2, right 1. And if we were to plug 1 into this function, I would get 2 times 1 is 2, minus 1 is 1. If I were to plug 2 into this function, I would get 4 minus 1 is 3. And if we look at this graph, right, 1, 1, 2, 3, and guess what? If I plug 4 into this function, or if I plug 3 into this function, I'm probably going to get 5, which 2 times 3 is 6, minus 1 is 5, which I do. Okay? And then all we have to do is connect it with a nice straight, missed a little bit over there, sorry. Nice straight line. Okay? Easiest way to graph. Start at the intercept, use the slope to get the next couple points, and draw the line. So let's do both of these. Y is equal to negative 3x plus 4. And let's not use a table. Let's just use the technique of intercept and then slope. So the intercept is 4. My slope is negative 3, which is negative 3 over 1. So that's down 3, 1, 2, 3, right 1. Down 3, right 1. Down 3, right 1. Also, the negative doesn't have to be attached to the 3. We could also say the slope is 3 over negative 1, which would be up 3, but left 1. And you can see that it does match up with my line. And if I were to draw a line, we would get a nice line, just like that. Missed that one a little bit, but let's do B, 4x minus 8. So now I start at minus 8, and I go up 4, 1, 2, 3, 4, right 1. Up 4, 1, 2, 3, 4, right 1. Up 4, 1, 2, 3, 4, right 1. And you get another line. Okay? As straight as possible. Okay? Slope-intercept form is useful for modeling real-life situations where you are given a starting value, the y-intercept, and a rate of change, like the slope. So let's model this function. Water pressure can be measured in atmospheres, ATM. Use the information in the diagram to write an equation that models the pressure, Y, at depths of X meters. What graph models the pressure? Okay, so here's our data points. At 0 meters, the pressure is 1 atmosphere. The pressure increases by 0.1 atmospheres per meter. Okay, so first we have to identify the slope and the y-intercept. So the slope is my rate of change. What is changing? Okay, well, we get 0.1 ATM per meter. That's the slope. Okay, the y-intercept is my starting value. At 0 meters, the pressure is 1. So my y-intercept is 1. So if I wanted to make an equation out of this, I would say y is equal to, right, remember it's mx plus b. So y is going to be equal to 0.1 x plus 1. Okay. To graph this, I'm going to have to start at 1 atmosphere. So I'm going to start at 1. Now this is tricky. To get the next point, I gotta go, well, I can go right 1, up 0.1, right 1 more, up 0.1, up 0.1, okay. But if I go right 10, that's up 1 whole 1, right? Because 0.1 is 1/10. So if I go right 10, that would be up 1, right? Or sorry, if I go up 1, right 10, that would be right 1, up 10, which would be equal to 0.1. Okay, remember slope is always rise over run. Okay, so now with my scale sort of mapped out, I can see I can get a very clear line going up, 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 up. Okay. One more, our Goddddd problem. So a plumber charges $65 for a repair plus $35 per hour. So the slope is going to be the amount of money that he charges per hour. So the slope is $35 per hour. My intercept is where we start, okay? And at zero hours, he still charges you $65. So my equation is y is going to be equal to 35x plus 65. Okay? And then when you make a graph like this, you obviously want to make it have a scale that makes sense. Okay, so we have dollars over here. We have time down here because that is my independent variable. Okay, so we're going to make hours 1, 2, 3, 4, 5, 6. And dollars, right? We're not going to go by ones because we're charging $35 an hour, so this graph would be very steep if we did. So let's go by 50s. 150, 200, 250. Okay? And not as clean as our, pre-rendered graph here, but we're going to start at $65. And then we are going to go up at a slope of 35. So after 1 hour, we're going to have to pay $100. After 2 hours, 2 times 35 plus 65, we're going to have to pay $135. Let's right there, about. And now we have our nice line, and we can see that if this guy stays in the house for 6 hours, 7 hours, 8 hours, we're going to wind up owing him a lot of money. Okay, so our lesson check. What is the equation of a line with a slope of 6, y-intercept of 4? So, whoops. So that would be y is equal to slope of 6, y-intercept of 4. Equation for there. So let's find the slope first, which would be -1 minus 4 over 2 minus -3, so that's 2 plus 3. So that's going to be -5 over 5, which is -1. And pick a point. Let's use the second one. So that's -1 is going to be equal to the slope times x plus b. So b is -2 plus b. Add 2 to both sides, and we get that b is equal to 1. So y is going to be equal to -x plus 1. Graph, start at 2, slope of 5. So start at +2, and then go up 5, right 1 to make the graph. Is y equal to 5 a linear equation? Yes, it is a linear equation because it only has, it doesn't have x to any particular other power like 2, 3, 4, or whatever. Okay, it happens to be a special kind of linear equation because it has no independent variable. Y is always equal to 5. The output is always 5. So if you think about it, if I have a graph, 1, 2, 3, 4, 5, if my output is always 5, it's going to be flat. Okay, so that is a horizontal line. Is it always, sometimes, or never true that an equation in slope-intercept form represents direct variation? Well, remember that direct variation has to go through the origin, right? We have to have y is equal to some constant times x. There can be no other number over here. So this would not be direct variation because of the minus 4. Now it is. If I take that 4 away, y is equal to 6x is direct variation. So the answer is sometimes. Linear functions can sometimes be direct variation. Describe two different methods you can use to graph the equation y is equal to 2x plus 4. You can plot points, right? We can make a table, but the better way is to start at positive 4, the y-intercept, and then to get my next point, you would go up to right 1. Use the slope. And that is 5-3 slope-intercept form.